Okay, so this is just a little re-review of solving equations. Remember that the best way to get better at solving equations is to solve them yourself. So rather than just watch me solve all of these, it would be better for you to do each of the problems yourself while the video is paused and then watch me to check your answer. So feel free to pause the video whenever you need to give them a try. So the first thing we went over was literal equations, which are like formulas where we have more than one variable. And in this case, we want to solve for b sub 1. So that means this is what I want to get by itself. So I've got lots of things that I need to get rid of in order to get that b sub 1 alone. First thing that I see is this big divided by 2. So the inverse of division is multiplication. So my first step is going to be to multiply both sides by 2 because that's going to cancel those out. So 2 times a is just 2a. And then that leaves me with this guy. Next, I want to get rid of this multiplied h. So the inverse of multiplication is division. So I'm going to divide both sides by h. Now this time, since I'm dividing by a variable and I already have another variable, this is not going to simplify. It's going to stay 2a over h because a and h are not like terms. And so then that's going to be equal to, since the h is canceled, I just have b1 plus b2. Final step, if I'm trying to get b1 alone, is to get rid of this added b2. So subtract b sub 2 on both sides. Again, these are not going to be like terms. They're both variables. I can't combine them. So I'm just going to leave it as it was. This term minus b2. And that's what is equal to my b1. I've gotten that letter alone, so I've accomplished my mission. Example 2 here, so asking, is this a solution? So whenever we ask, is it a solution, that means we plug in and simplify. So plug in -3 in place of x, so 7 minus 5 times -3 equals, we're trying to figure out, 22. So order of operations, PEMDAS, I have to do multiplication before subtraction here. So don't do 7 minus 5. You have to do the multiplication first. -5 times -3 is positive 15. And so then 7 plus 15 is 22. Since this is a true statement, that means that yes, a -3 is a solution to that equation. All right, the next 4 are all just straight solve the equation, which means we're trying to get the variable by itself. So remember those 4 steps that I went over with you guys. Look back at your notes, make sure you know them, make sure you're saying them to yourself. So first step is to simplify the individual sides. Left side, these aren't like terms. Right side simplified, that's done. Step 2, all variables on one side. In this equation, all my variables are already on the left, so that's done. Step 3, move my constants to the other side. So since my variable's on the left, I want to move this constant over to the right. And I do that with subtraction because it's the inverse of addition. Those go away. -4 minus 5 is -9. Now, typically step 4 says get the variable alone, but that's already done, so we are finished with that equation. Now, over here, left side's fully simplified, right side's fully simplified. All my variables are already on the left, so that means my next step is to move constants to the right. So I have a subtracted 1. The inverse of subtraction is addition, so add 1 to both sides. That gives me 2/3 x equals 6. We talked about these fractions in the 2-3 video. Remember that fractions are special, and the inverse operation for a multiplied fraction is to multiply by the reciprocal, which is 3/2. So whatever I do on one side, I also have to do on the other side. So these will cancel out. Normally I could use a calculator, but I don't have one out right now, so I'm just going to do this by hand. On the top I have 6 times 3, which is 18. On the bottom I have 1 times 2, which is 2, and 18 divided by 2 is 9. And my variable is now alone, which means that I'm good to go. All right, number 5 here. This time I have some simplification to do. Step 1 is not finished because I have some distributing that needs to happen on this left side. So -6 times x is -6x. -6 times -2 is +12. So now the left side is simplified because these are not like terms. One's a variable, one's a constant. Right side is also simplified for the same reason. So I move on to step 2, where I get all my variables to one side. Doesn't matter which side. I like to add rather than subtract, so I'm going to add 6x to both sides and get all my variables on the right. So that means I have 12 equals 14x minus 16. So if my variables are on the right, that means I need my constants on the left. So add 16 to both sides here. 16 plus 12 is 28, so I have 28 equals 14x. And then step 4, get the variable alone. So right now I have a multiplied 14. I need to undo that multiplication with division. 28 divided by 14 is 2, and my x is alone. Last one. Again, I have some distributing that needs to be done on the left side rather. So 3 times 3 is 9. 3 times 4y is 12y. So my left side is as simplified as it can get. So is my right side. So next, I want all my variables on one side. So I'm going to move to the left this time. I'm going to subtract 12y on both sides. That cancels this. Over on the left side, though, those cancel too, which means I'm left with 9 equals -9. So this is one of our special cases. When my variables drop out, I need to decide what the answer is, and that's based upon whether what's left is a true statement or a false statement. So you ask yourself, does 9 equal -9? And hopefully your answer is no, they're not equal, which means that because this is a false statement, that means the answer is no solution. If it was a true statement, remember that the answer would be infinitely many solutions. If you're still confused about those, that was in the 2-4 lesson and ed puzzle there. All right, last one. Writing equations from word problems. Nisha bought 10 packages of candy at the store, all Skittles and M&Ms. The number of Skittles packages was 2 less than triple the number of packages of M&Ms. write an equation to model the situation using M to represent the number of packages of M&Ms. So I know that in general, my approach should be number of Skittles plus number of M&Ms equals the total. And in this case, I'm told that the total is 10. I'm also told to use M to represent the number of packages of M&Ms. So I know I'm going to have Skittles plus M equals 10. Again, when you write an equation, you cannot introduce another variable. It has to be only one variable. So what we have right here tells me how to write the number of Skittles in terms of M. So it says the number of Skittles was 2 less, so that means I'm going to be subtracting 2, then triple. Triple means times 3. Triple the number of packages of M&Ms. Well, the number of packages of M&Ms is M, so times 3 is 3M. So 3M minus 2, this represents Skittles. This is how many packages of Skittles she bought, plus the number of packages of M&Ms equals the total, which was 10. So that's our equation. Part B, solve that equation. So I'm going to rewrite it. Step 1, I need to simplify on this left side. There's no distributing, but I do have like terms here. 3M plus M is 4M. And then I've got my minus 2 equals 10. So left side is now completely simplified. Now my variables are all on the left, which means I need to move constants to the right. So add 2 to both sides. 4M equals 12 is what that gives me. Then get M alone. Right now, this is a multiplied 4. So I'll undo it by dividing. And I get M equals 3. Now be careful. It says solve your equation to find the number of packages of each kind of candy. So M was M&Ms, so 3 M&Ms, which means since the total was 10, that she had to have bought 7 Skittles. Okay. Hopefully that extra practice and extra explanation helps you to feel prepared for your solving equations quiz. Make sure you reach out if you have any questions on these.